Welcome to Ganithalay. This is Meeravali. In this video, we are going to discuss about the topic circles. In circle concept, our lesson is chord of contact and pole and polar, conjugate points and conjugate lines. Okay, let's start the topic. Chord of contact. So look at here, chord of contact means first we have to consider a circle, let it be center C, and also taken a point P x1 comma y1. This is a point on the exterior of the circle. So by taking external point, how many tangents we can draw here to the circle from the external point? Here we can draw two tangents from the external point of the circle. Suppose I am going to draw a tangent here like that. Let this tangent touches the circle at a point A. Okay, next one. Another tangents we can draw from this point like that. Okay, take this point as A. This is a point P. So let us take the point of contact of another tangent to the circle is some B. So that means first we have taken a circle S is equal to 0 and a point P is can be taken exterior side of the circle. So we know that there are two tangents can be drawn from an external point P to the circle. Suppose these two tangents meets the circle in A and B. If you join this point of contact, you will get a chord. This chord is called the chord of contact of the circle S is equal to 0 of the point P. Okay, this is called. Now we have to say that this is called the chord of contact of P with respect to the circle. So this is the definition. So look at here the definition. A line joining the points of contacts of the tangents to the circle S is equal to 0 drawn from the external point P is called the chord of contact. That means first we have taken a circle S is equal to 0 like that. This is the circle. Next one, an external point P can be taken here. After taking the external point P, now we can draw two tangents, this one and this one, to the circle S is equal to 0. Now these two tangents meets the circle in 2 points A and B. Now if you join these 2 points, you will get a chord. That chord is called the chord of contact of P with respect to the circle S is equal to 0. So that is the definition of the chord of contact. Okay, so to find the chord of contact of the circle, we have first of all a equation of a circle and an external point of the circle. Okay, so by using these 2 points, now we can find the equation of the chord of contact. So now we have to write formula for the equation of the chord of contact. So to find the chord of contact, let S is equal to 0 be the circle and P be a point, be an external point. Now we are going to find the chord of contact. Then the equation of the chord of contact of P with respect to the circle S is equal to 0 is the formula S1 is equal to 0. This is the chord of contact formula. Okay, so now we are going to find the chord of contact problems. Okay, let's start the problem here. Find the equation of the chord of contact of P 2, 5 with respect to the circle x square plus y square, so and so will be given. So here what are given? First you have to write, given that the point, what is the point here? Given P 2, 5. Next one, we have a equation of the circle. Therefore equation of the circle is, what is that? So equation can be taken as S, x square plus y square minus 5x plus 4y minus 2 is equal to 0. First we have to take in the what are the given. So after taking the given point, what we have to find here? The equation of the chord of contact. Okay, what is the formula for chord of contact? Already I have told you. Therefore the equation of chord of contact of P with respect to the given circle S is equal to 0 is, the formula is S1 is equal to 0. Students, remember that how to write the S1 here. So by taking S is equal to 0, so by taking this one, we need to find the S1 is equal to 0. S1 means we have to write x square means x into x. So 1x can be written as x1. Y square means y. So that means y1. Next we can make the half of x coefficient. That means now after that x plus x1. Next plus y coefficient here 4. It can be half of y coefficient. You will get y plus y1. Now constant will be taken like that. Now then take the point, this one x1, this is y1, and put x1 y1 as 2 and 5. Now we will get x into 2 plus y into 5. Next minus 5 by 2, there is no cancellations, plus 2 plus 2 ones 2 2s are. Now 2 into y plus y1 means 5 minus 2 is equal to 0. Now simplifying, 2x plus 5y. Now minus 5 by 2 into x plus 2. Next plus 2y plus 10 minus 2 is equal to 0. Now taking LCM here, you will get by 2 is the LCM. So LCM 2. Now taking by 1 here and also by 1. Now you will get 4x plus 10y. Next minus 5 into x, 5x minus 5 into 2, 10, plus multiplying by 2, 2 2s are 4y, 2 10s are 20, minus 2 2s are 4 is equal to 0. Now doing cross multiplication, you will get here 4x minus 5x minus x. Next one 10y plus 4y, 14y plus 14y. Next constant terms, minus 10 plus 20 plus 10 plus 10 minus 4 plus 6 is equal to 0. Now finally taking minus common, you will get x minus 14y minus 6 is equal to 0. This is the chord of contact equation. Okay, this is the chord of contact equation. To find the chord of contact equation, first we have an external point of the circle and equation of the circle. Now the simple formula is S1 is equal to 0. This is the procedure to find the chord of contact. Okay, next. Okay, this is the one more problem. First we have to write what are given. Here we have seen a point and a circle. First you should write, given that the point can be taken as P11. Next given circle, this one. So now the circle can be considered as x square plus y square minus 9. Take out the constant from right to left. So this is yes. Now we are going to find the equation of the chord of contact. So the formula is the equation of the chord of contact. Contact is the formula S1 is equal to 0. Now by taking S here, this one, now you have to write xx1 plus yy1 minus 9 is equal to 0, that is S1. Now x1 y1 means this is x1 and this is y1. So x1 means 1, y1 means 1. Now put here 1 plus y into 1 minus 9 is equal to 0. That is x plus y minus 9 is equal to 0. So this is the chord of contact equation. Okay. Now I am going to give you some more problems on this model. So make them. Okay. Practice this problem and you will make an answer. Okay. So this is the problem on the chord of contact. Now let's see another problem. Okay. Look at the problem here. If a chord of contact of P with respect to the circle, here the circle will be given, let it be circle equation, this is S is equal to 0, this is the circle. Okay, chord of contact of P with respect to this circle means, first we have to take a point P, some x1 comma y1 on the exterior of the circle. So the chord of contact of this point P means, so if you draw a tangent to this circle, it will meet the circle in capital A, and also another tangent can be drawn, it will cut the circle in B. So that means the chord of contact of P means, so it will be formed by like that. This is the one tangent and this is one more tangent. So now the chord of contact is AB. AB is our required chord of contact. So this is chord of contact of P. So first we have to find the chord of contact of P. Now after that, the center of what is the given circle here? X square plus y square is equal to a square. So look at here, x square plus y square is equal to a square is a circle equation. If you observe here, there is no x coefficient and y coefficient. That means there is no x term and y term in this equation. Then this form is called the standard form. In the standard form, we have taken the center is origin. That means 0, 0 is the origin. So now the center can be taken as, let it be center of the circle. So this is the origin here, because of the given circle is in the standard form. Okay. So let us take the given circle here. Given circle is, suppose if you taken this one as x square plus y square minus a square, where center C 0, 0 and radius r is equal to a. So this is the this is about the center and radius of the given circle. So let what are given here, let P be the exterior point of the circle. Let P x1 comma y1 be a point. So here the chord of contact of P to the circle cutting the circle at A and B. Okay, this chord of contact, this is the chord of contact, this will cut the circle in A and B, that is given here. So first we have to find the chord of contact equation. Now the equation of a chord of contact of P to the circle S is equal to 0 is the formula S1 is equal to 0. where what is the s here? This is the s here. By using this one, you can write s1 means x(x1) plus y(y1) minus a square is equal to 0. So this is, let it be equation 1. Now what is given here? The chord of contact cutting the circle at A and B. So let A, B are the, so that means given A comma B are the points of intersection. Points of intersection of 1 with the circle S is equal to 0. And also given here angle AOB is equal to 90 degrees. That means angle AOB means by joining A to the origin, this one, and by joining O to the point B. So that means here the angle will be given, that is 90 degrees will be given here. This angle is 90 degrees. So that means we have to make the homogenization of equation 1, homogenize the equation, circle equation with the equation 1. You will get a pair of equations, pair of straight lines AO and OB. So we need to find the equation of the pair of equation of the OA and OB, okay, by taking the equation of the circle. Now that means to find the homogenization method here, so with the line AB and curve, by using the curve. Now from equation 1, so while you are going to making the homogeneous method, by taking the line equation, we have to find the constant 1 here. So what is the constant in this one? A square. Take it right side. So I'm dividing by a square on both sides. You will get this one. Let it be equation number 3. Now by using this third equation, we have to homogenize the equation S is equal to 0. So now homogenizing 1, that means S is equal to 0 by the equation 3. So what is the S is equal to 0 equation? This is x square plus y square, here degree 2, here degree 2, this is the constant term. So this can be written as a square into 1 square. So that is homogenization, meaning that one. Now x square plus y square minus a square into 1 square, that is homogenizing, means we have to equating the power of every term. So that is x square plus y square minus a square into 1 means, from the equation number 3, the 1 value is xx1 plus yy1 by a square. This is the 1 value, and also having power 2. So here a square is not the variable, so this is the constant term. That's why we have taken 1 whole square. Okay, now it will be homogenized. Okay, so by using this one, we can making x square plus y square minus a square into, now separating the power here, xx1 yy1 whole square by a square whole square, means a power 4 is equal to 0. Now a square and here a square cancel. Now you will get here x square plus y square minus of xx1 plus yy1 whole square by a square is equal to 0. Now here making LCM, a square into x square plus y square, next one minus of, if you expand this one, a plus b whole square, x square x1 square plus y square y1 square minus 2a x y x1 y1 into xy is equal to 0. So that means This is the pair of equation passing through the origin. So it will be arranged in the form of general form. That means we can take the x square term x square common. So here x square there, here x square there. The coefficients are a square minus x1 square. After that you can write the x into y term. Here this is the x into y term. So minus into minus plus 2a into x1 y1 into xy term. After completing this one, you have to write y square term. So by taking y square common here, you will get here a square minus y1 square is equal to 0. So let it be equation number 4. Okay, which is the pair of equation passing through the origin. Which is the pair of equation of AO and OB. Okay, given that angle AOB is equal to 90 degrees, so that means x square coefficient plus y square coefficient is equal to 0. This is the formula in the topic pair of straight lines. Now what is the x square coefficient here? This is a square minus x1 square plus y square coefficient means here a square minus y1 square is equal to 0. Now bring out x1 square y1 square to right side. So now plus x1 square plus y1 square. Now a square plus a square on left hand side, 2a square. So therefore the equation of locus of P is, we can write here x square plus y square is equal to 2a square. Now we have to show that the P lies on the circle, this one. So P lies on the circle means the locus of the equation of P will be x square plus y square is equal to 2a square. This is the answer. Okay. This is about the chord of contact. Now we are going to discuss about the pole and polar. Okay. Okay, look at here. Now we are in pole and polar. So what is the pole and what is the polar here? So first we have to take a circle S is equal to 0. Okay. This is the circle S is equal to 0 I have taken. And P be a point, and a point can be taken here. So here the point will also taken either interior or exterior or on the circle. Suppose for explanation I have taken a point P exterior of the circle. So after taking the point P, if any line drawn through the point P which meets the circle in 2 points. Now we are going to draw a line through the point P which cuts the circle into 2 points. Okay, suppose I have to take a line through the point P like that. Suppose this will meet in the circle at A1 and B1. Okay, then the point of intersection of the tangents drawn at A and B lie on the line. That means if you drawn a tangent at the point A and B, that means at a point A1 and B1, suppose I have to draw a point tangent at A1 like that, and also a tangent at B1. So you will get the point of intersection of the circle at a tangents A1 and B1, that will be say something some Q1. Next, in the same process, if you take one more line which cuts the circle in 2 points through the point P. Okay, suppose I am going to take another point, another tangent like that, another intersecting line of circle. Suppose it will meets the circle in 2 points, let A2 and B2. In the same process you will continue the tangent at A2 and the tangent at B2. Now you get another point of contact, let it be point of contact Q2. If you joining the point of intersection of the tangent at the point of intersection of a line through the point P, okay? If you joining Q1 and Q2, you will get a line like that. Okay, this line is called the polar of P. Okay, this is called the polar of P. So that means to draw a polar of P, first you need to take the circle S is equal to 0 and point P. By taking this point, you can draw a intersecting line to the circle. It will meet the circle in 2 points. At these points, if you draw 2 tangent at these 2 points, they will meet a point. Now that point, the locus of that point is called the polar of the point P. So that is the concept. Okay, so here the line, this line is called the polar of P with respect to the circle, and the point you have taken either exterior or interior or on the circle, that will be called the pole of the line. That means if one polar will be there. If you taken a polar, one pole will be there. Okay, this is the concept about the polar. Now the polar can be existed on depending on the point you have taken. So let us discuss about that conditions. Okay, let me discuss about the different form of the polar. Okay, if you taken a point P outside the circle, so that means like that. So look at here, if you taken a point P outside of the circle, now the polar, this is the polar, this polar will be the intersecting of the circle in 2 points. So this polar meets the circle in 2 points, that they A comma B. So that is here. In this case, if you take any point P outside of the circle, now the polar will be the chord of contact of the point P. Polar will be the chord of contact of P. So that is the first condition. If P lie outside of the circle S is equal to 0, then the polar of P meets the circle in 2 points, and especially the polar becomes the chord of contact of P. In second case, if P is a point which lie on the circle, if you take any point P on the circle, this is the point P on the circle, now the polar of P, so this polar of P is the tangent at that point. So that means if you take any point with respect to the circle, that means the polar will changes with respect to the position of the point. Okay, so that means if you taken a point P outside of the circle, the polar will be the chord of contact of P. Now if you taken P on the circle, now the chord of contact is becomes a tangent at the point. Next one, if you taken P inside the circle means there will be 2 cases are there. If you taken a point interior of the circle, so here this is the center of the circle. Now if you taken our point P other than the center, that means P, in this case the polar of P does not meet the circle. Now the polar of P does not meet the circle. Okay, so this is the concept. Suppose if you taken a point interior of the circle and also that point will be as a center, in this case the polar does not exist. because of that one, because of to take in the center. Okay, because of if you drawn a intersecting line through the center, it will meet the circle at the ends of the diameter. If where ends of the diameter can be taken capital A comma capital B, if you drawn the tangent, there will be no point of contact because of at the ends of diameter the tangents will be parallel to each other. So in this case the polar does not exist. They are the different forms of the polars by taking different position of the point with respect to the circle. So finally, to find the polar equation, what is the formula we have to use? Okay, that is our concept. So now to find the polar equation, we need to have the point and circle. Okay, now the formula is the polar equation. The polar of P with respect to the circle S is equal to 0 is, that is the formula S1 is equal to 0. Here S1 is equal to 0 can be used to find the equation of a tangent at the point and the chord of contact of the point P, and also now use it to find the polar of the point P with respect to the circle S1 is equal to 0. This is the very important formula. Okay, so to find the polar of the P, polar of a point, we have to use the formula S1 is equal to 0. Let's start the problems on this method. Okay, let us see the problem here. What are given here? A point will be given and an equation of a circle will be given. What we have to find here? Polar equation. So let us write the what are given. Given that a point, let it be P 2 comma 3. Next one, given circle, his circle can be taken as S, so which is x square plus y square, so x plus 8y minus 96. This is the equation of the circle. Now we are going to find the polar. Now therefore the equation of a polar of P 2 comma 3 with respect to S is equal to 0 is the formula S1 is equal to 0. S1 is equal to 0. So while you are going to write S1 formula, you have to use the S is equal to 0. So by x square means you can write xx1. Next y square means y into y, that means 1y can be written as y1. Next you have to take the half of x coefficient 3 into x plus x1 here. Next half of y coefficient, that is 4 into y plus y1 and same to same constant. Okay, so this is, so here you have to substitute x1 is equal to 2, this is y1 is equal to 3. Now x into 2 plus y into 3 plus 3 into x plus 2 plus 4 into y plus 3 minus 96 is equal to 0. Here 2x plus 3y plus 3x plus 6 plus 4y plus 12 minus 96 is equal to 0. So first you have to write x terms, 2x plus 3x 5x, next y terms 3y plus 4y 7y, now constant terms 6 plus 12 18 minus 96, that is 8, next one 7, so finally minus 78 is equal to 0. This is the procedure to find the equation of the polar. Okay, let you complete this problem. Okay, take it this problem as a homework sum and find the answer. Okay, next we will go for some conceptual problems on the polar and chord of contact. Okay, look at here, this is the problem here. Read the given problem carefully here. If the polar of the point P, So if the polar of a point, suppose we have taken a point P first of all, let it be x1 comma y1. So for that point we have to find the polar of this one. Okay, polar means that is a line. Now by taking a point P with respect to this circle, we need to find the polar of P first of all, that one. Okay, polar of a point of this one, that means point can be taken on this circle. Okay, so by taking point on this circle, we have to find the polar of that point with respect to this circle. Okay, that means polar can be found by using this circle. So then you will get a polar equation, and given that polar touches the circle this one, that means that polar becomes a tangent to this circle. Okay, so here the simple concept is, first we need to take a point on this circle, after that taking point on this circle, we need to find the polar of that point with respect to the second circle. Okay, now that polar will touches the circle x square plus y square is equal to c square. That means now our polar will become a tangent to this circle. Now here, if a line touches a circle, there will be a condition, we have to use there that condition. After that you will get the condition. But we have to show that here, we need to show that A, B, C are in geometrical progression. Here A, B, C are in geometrical progression. So to show this one, it is enough to show that geometric mean. Here geometric mean, what is that? B. Mean means middle value. Geometric mean is equal to square root of the product of the extremes. So to prove this A, B, C are in GP, it is enough to show that B is equal to root AC or B square is equal to AC. If you show this one, now the problem will be completed. Okay, look at here. First we have to take the given three circles. Given circles are x square plus y square is equal to a square. This is equation 1. Next one, this is equation number 2. Next, x square plus y square is equal to c square. This is equation number 3. Now we have to take in here polar of a point of the circle 1. So let P x1 comma y1, this point can be taken on the circle 1. P be a point on the circle 1. So when you have taken point on this circle, it will satisfy the equation 1. Now we can write x1 square plus y1 square is equal to a square. Let it be equation number 1. Now by taking a point on this circle, we have to find the polar of that point with respect to this circle. Now we need to find the polar of P with respect to the second circle. So the second circle can be taken as S here. Now the polar of P with respect to circle 2 is, if you taken the second circle as S, now S1 is equal to 0 is the answer. So here you have to use the second circle, that is xx1 plus yy1 is equal to b square. Okay, so this is the equation number 2. So this can be, now we will convert this one into standard slope intercept form. Because of this equation, this polar will touches the third circle. So if a line touches a circle, there will be a property. So for finding that one, we have to convert the given polar equation, this polar equation, into slope intercept form. So here the slope intercept form is y is equal to mx plus c. On left hand side, we have to arrange y term and remaining term take to right side. Okay, so for that y1 is equal to minus xx1 plus b square will be there. After that, dividing by y1, you will get here minus x1 by y1 into x plus b square by y1. Okay, this is, so here this is of the form y is equal to mx plus c, where m is equal to minus x1 by y1, c is equal to b square by y1. So here given that, let it be equation number 5. Given that here the polar of p with respect to the second circle, that means equation number 5 is a tangent to the third circle. So for the third circle, where radius r is equal to, what is that, c. So where radius r is equal to c here. Okay, now tangent to the circle, now the property is here c square is equal to r square into 1 plus m square. This is the property, where c means this one, p square by y1 square whole square is equal to r means here the radius of the third circle, what is that, c. So now c square into 1 plus m square. M means this is the m value, minus of x1 by y1 whole square. Now here b power 4 by y1 power 4 is equal to c square into 1 plus x1 square by y1 square. So minus square means plus. Now you can write here b power 4 by y1 power 4 is equal to c square into x1 square plus y1 square by y1 square here. So by cancelling y1 square here, y1 square, you will get here b power 4 is equal to y1 square into c square into x1 square plus y1 square. Okay, here a little mistake will be done. Here we have to, m value means y1, c value also b square by y1, there is no y1 square. Now you will get here square. Now after that, here also you can get square, not power 4. So this is square. Now cancelling this one and this one, you will get here p power 4 is equal to c square into x1 square plus y1 square. Now from equation number 4, here from equation number 4, x1 square plus y1 square is equal to a square. You can substitute x1 square plus y1 square value in this one. You will get here b power 4 is equal to c square into a square. Now making square root on both sides, p square is equal to ca or ac. So finally what you have to write, now b is equal to root of ac. Therefore a, b, c are in GP. This is the concept. Okay. Okay, this is the important problem for 4 mark question. Okay. Okay, look at here. This is a problem. Show that the poles of tangent to the circles, this one with respect to the circle, lie on the line. That means the poles of tangent to the circles. First we have to take in a point P. So by taking that point, we need to find the polar of the second circle. Okay, so that polar will become a tangent to the first circle. That is the concept of this problem. Okay, so finally you can show that point P lie on the y square is equal to 4ax. Okay, so let us take the given problem properly here. So here you have seen the two circles. So let given two circles, given circles are x square plus y square is equal to a square. This is circle 1. And next one, another circle, x plus a whole square plus y square is equal to 2a square. Convert this second circle into general form. So a plus b whole square expansion plus 2ax plus y square. Now take it right side, 2a square, left side. So first you have to write x square plus y square, next x term, next there is no y term, here constant plus a square minus 2a square minus a square is equal to 0. This is equation number 2. Now read the given problem carefully. The poles of tangents to the circle with respect to the second circle. That means the pole of the second circle. Okay, that means we need to find the polar of the second circle here. So let P x1 comma y1 be a point. Therefore, the polar of P with respect to circle 2 is, so if you take a second circle as S, now you can write S1 is equal to 0. So here by taking the second circle as S, now you have to write S1 as xx1 plus yy1 plus half of x coefficient. 2a can be halved, you will get a. Now x plus x1 minus a square is equal to 0. Now this can be converted into line general form. Polar means line, so every line is of the form ax plus by plus c is equal to 0. That means first you have to write x term, here x term. So by taking x common here, you have to write x1 plus a into x. After that y term, this is the only y term, so y1 into y. Next one constant term, x1 into a, ax1. Next one a square. So this is equation number 3. Now convert this equation into general form. Now you can get here, general form means slope intercept form. So for slope intercept form, convert, we can write the left hand side y term and remaining terms should be on right hand side. Now y1 is equal to minus of x1 plus a into x minus of ax1 minus a square. Now y is equal to minus of x1 plus a by y1 into x minus of ax1 minus a square by y1. So this is equation number 4. Now consider it as y is equal to mx plus c, where m is equal to x coefficient, that is x1 plus a by y1. C means minus ax1 minus a square, that is minus of ax1 minus a square by y1. Now here given that 4, that means polar of P, that is 4, is the tangent to circle 1. Now the property, what is the circle 1 here? X square plus y square is equal to a square. This is in the standard form. So that's why we need to convert the given tangent polar equation into y is equal to mx plus c. Now the property is c square is equal to a square into 1 plus m square. Now substitute here, c means constant here, this is minus of ax1 minus a square by y1, this is c, and whole square is equal to a square into 1 plus m means this is minus of x1 plus a by y1, okay, m square. Okay, finally you can simplifying carefully here. So minus square means plus, and ax1 minus a square whole square by y1 square is equal to a square into 1 plus minus square means plus. Here separating the square to numerator and denominator, you will get this one. So finally you have to write here ax1 minus a square whole square by y1 square is equal to, now a square into taking LCM, y1 square plus x1 plus a whole square by y1 square. So here a square cancel. Now finally you have to write here, this is of the form a plus b whole square. Now a square x1 square plus a to the power of 4 minus 2a cube x1 is equal to a square into y1 square plus x1 square plus a square plus 2ax1. Now simplifying here, is equal to a square y1 square plus a square x1 square plus a to the power of 4 plus 2a cube x1. Now cancelizing carefully here, a square x1 square cancel. Now a to the power of 4 cancel. Now finally you can get here on left hand side minus 2a cube x1 is equal to a square y1 square plus 2a cube x1. Now you can take common here, right hand side, a square. Now minus 2a cube x1 is equal to a square into, otherwise take it 2a cube x1 to left side, you will get here a square y1 square is equal to minus 2a cube x1 minus 2a cube x1. Now finally you have to write here a square y1 square is equal to minus 4a cube x1. Now cancelizing a square and a cube here, you will get here a here. Now y1 square is equal to minus 4a x1. This is our required answer. Now observe that here, therefore finally p x1 comma y1 lie on the line y square is equal to minus 4ax. Okay, this is the concept for x. So now finally p x1 comma y1 lie on the line, on the curve y square is plus 4ax is equal to 0. This is, we have to show that. Okay, this is the conceptual problem. Okay, now we are going to find the we are going to discuss about the conjugate points and conjugate lines. Okay, let's start the topic. Okay, now we are in conjugate points. So conjugate points means, first in the problem 2 points are given. Now we have to show that these 2 points are conjugate points. So the definition of conjugate point means, if the points p comma q, so suppose p x1 comma y1 and q x2 comma y2, if we can take these 2 points here and a circle s is equal to 0 will be taken. Now we have to show that the 2 points are conjugate. Conjugate means, first either of the 2 points we need to take a point first of all. By taking a point P to find the polar equation S1 is equal to 0. Okay, after finding the polar of the first point, now that polar will satisfy the point 2. That means if you substitute the point Q in this equation, that means S1 is equal to 0, you will get it is satisfied. That means this point can be substituted in this one. Second one, h2, it will satisfy. That means s12 is equal to 0. This is the concept of the conjugate points. That is the property. 2 points P and Q are said to be the conjugate points with respect to the circle if the polar of P, if you may also taken polar of Q here. If you taken polar of P with respect to the first circle S is equal to 0, that will passes through Q. That means that line passes through the point Q. This may also taken as that line, that point Q satisfies the polar of P. If you taken here polar of Q with respect to S is equal to 0, that passes through the point P. Okay, that is the polar property, conjugate points property. So finally the conjugate points property is S12 is equal to 0. That is the property. Okay, so that means we have to write here the property is the points P comma Q are conjugate points with respect to the circle S is equal to 0, then S12 is equal to 0. This is the condition that the 2 points are conjugate points. Okay, let's see the problems on this model. Okay, let's see the problem here. Show that the points 4, 2, 3, -5 are conjugate with respect to the circle. Here you seen here 2 points. Let the given points are first capital A 4, 2. Next point will be taken B. So next what will be given here? Given circle. So given circle can be taken as S. So x square plus y square minus 3x minus 5y plus 1 is equal to 0. This is the given circle. Now what we have to show that here? The 2 points are conjugate. What is the conjugate property here? S12 is equal to 0. Okay, that means you have to find S12 answer. You will get the answer will be 0. That is the process. Therefore for S12 is equal to, so here S is this one. By using this one you have to write S1 like that. X square means x into x. So here one x can be written as x1, another one is x2. In the same way y1 y2, and making half of x coefficient and x1 plus x2. Next plus half of y coefficient 5 by 2, y1 plus y2. Next plus 1. So don't write here 0. We have to show that 0. This answer should be 0. Now is equal to, by taking this one x1 and this is y1, this is x2 and this can be y2, and substitute in this equation carefully. You will get here x1, that is 4, into x2 is 3 plus y1 2 into y2 minus 5 minus 3 by 2 into x1 4 plus x2 3 minus 5 by 2 into y1 2 plus of minus 5 plus 1. So now simplifying here, 12 minus 10 minus 3 by 2 into 7 minus 5 by 2 into minus 3 plus 1. Now taking LCM here and also simplifying, 12 minus 10 minus 21 by 2 minus of minus plus 15 by 2 plus 1. Now adding the without fraction values, 12 minus 10 2, 2 plus 1 3. Next minus of plus 15 minus 21 by 2. You will get here 3 minus 6 by 2, that is equal to 3. 2 1s are 2 3s are minus 3, which is equal to 0. Finally you have considered here S12, it will gives the answer 0. So if S12 is equal to 0, now the first point A and second point B in S12, first point A, second point B are conjugate. Therefore, given points are conjugate. Points are conjugate with respect to the circle S is equal to 0. This is the procedure to showing the conjugate points. Okay. Let's see the problem. This is the very important problem for 2 marks questions. Okay. First read the given sum carefully. Find the value of k if the points this one and this one are conjugate with respect to the circle. That means here given sum having two points and a line, a circle. So first you have to write the given points. Given points can be taken as capital A 1 3, second point can be taken as capital B 2k. Next, taken the given circle. So circle also taken as S, x square plus y square. Take it constant to left side. So 35 is equal to 0. So once more I have to check the given problem. X square plus y square is equal to 35. Okay. Now what we have to show that here? So sorry, you have to find the value of k. To find the value of k, what is the given condition? If the points A and B, this point can be taken as A, this is B, AB are conjugate. That means in the problem the 2 points will be given as conjugate. Therefore, given that A comma B, A and B are conjugate. Conjugate with respect to S is equal to 0. So therefore, the property will be S12 is equal to 0. By taking S, we have to write here on left hand side S12 like that. X1 x2 plus y1 y2, next minus 35, that is left hand side. Also right hand side 0. Now you have to write this is x1, this is y1, this x2 and this one y2. Now put in this equation carefully here. X1 means 1 into x2 2 plus y1 means 3 into y2 means k, minus 35 is equal to 0. Now 2 plus 3k minus 35 is equal to 0. Finally 3k minus 35 plus 2, 33 is equal to 0. 3k is equal to 33. Now k is equal to how much? 33 by 3, which is equal to 11. 3 ones, 3 11s. Okay. So therefore the value of k is equal to 11. So this is the procedure to find the value of k when the 2 points are conjugate. Okay. Have a look on this problem. Okay. Look at here. This is also one more important problem for 2 marks question. Okay. Look at the problem here. Find the value of k if the points, let this point is A, this point is B, are conjugate with respect to this circle. Circle can be taken as S. Okay. So we have to find the value of k by taking A point, B point are conjugate. Okay. First write the given 2 points here. Given 2 points are given points. Let A 4 2, B k minus 3, given circle. Circle can be taken as S, x square plus y square minus 5x plus 8y plus 6 is equal to 0. This is the given circle. Now what are given here? If the points are conjugate, that means suppose we have to take AB are conjugate. Conjugate with respect to the given circle S is equal to 0. Then the property is S12 is equal to 0 is the property for conjugate points. Now by taking here S, we have to write S12 carefully. X square means x into x, one is x1, another one is x2, plus y1, y2. Now half of x coefficient, x1 plus x2. Next half of y coefficient, 4 into y1 plus y2 plus 6 is equal to 0. Now substitute x1, this is y1, and this one x2, this is y2. Now carefully in this equation we can substitute. Now x1 4 into x2 k plus y1 2 into y2 minus 3 minus 5 by 2 into x1 4 x2 k plus 4 into y1 2 plus of minus minus 3 plus 6 is equal to 0. Now 4 into k, 4k, minus 2 into minus 3, minus 6, minus 5 by 2 into 4 plus k, plus 4 into minus 1 plus 6 is equal to 0. Now you have to write here 4k, next minus 6, minus 5 by 2 into 4 plus k, minus 4 plus 6 is equal to 0. Now simplifying here 4k and minus 6 minus 4 minus 10 plus 6 minus 4 plus minus remaining value 5 by 2 into 4 plus k. Now making LCM here by taking here 1, so 2 into 4k minus 4, 8k minus 8 minus 5 4s are 20 minus 5k by 2, and making cross multiplication you will get here 0. 8k minus 5k, 3k minus 20 minus 8 minus 28 is equal to 0. Now k is equal to 28 by 3. This is the answer. Okay, this is the procedure when the 2 points are conjugate and find the value of k. Okay, so I will give you some more problems on this model. Okay, make them homework. Okay, take it these 2 problems as homework sum. Okay, now we are going to discuss about the conjugate lines. Before going to discuss about the conjugate lines, in before problems, if point will be given, then how to find the equation of polar, that we have seen. Now we are going to discuss about the to find the pole when the polar will be given. Now let's see the concept. Okay, look at here. This is the question. In this question, if Lx plus My plus N is equal to 0 is a polar with respect to the circle x square plus y square plus 2gx plus 2fy plus c is equal to 0, then the corresponding polar of the given line is this one. Okay, this is we have to show that. So in the given problem, what are given here? Given a line. Given that a line Lx plus My plus N is equal to 0. This is a line. Next, what will be given? One more. Given that a circle. Circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is the circle equation. Let it be equation number 2, or circle can be taken as S. Okay. Now what we have to find here? Pole. So let Px1 comma y1. Pole means a point, polar means a line. Okay. For a polar there will be unique pole. In the same way, for a pole there will be a unique polar. That is the polar and pole concept. So to find the pole, I have taken, let Px1 comma y1 be a pole of 1 with respect to 2. circle S is equal to 0. By using the formula, the polar of P is S1 is equal to 0. Now here S1 means by taking S this one, you have to write xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. When you have used S1 is equal to 0, you will get a line equation. Line equation means it having the general form ax plus by plus c is equal to 0. That means first you have to write the x term. Here x and here x is there. If you take an x common, x1 plus g is the x coefficient. Next, after that you have to write the y term. So y term is here y coefficient y1, and in this one plus f. Now you will get the y coefficient y1 plus f. After that the remaining terms. What are the remaining terms? x1 into z, x1g plus f into y1. That means y1f plus c. This is the totally constant. So equation number 3. What is the equation number 3 here? Here we have taken the polar of P is the equation number 3. But what we have taken here, P be the pole of the line 1. Okay now? Here the 1 and 3 both are the polars of the point P. But we know that for a pole there will be a unique polar is there. But in this problem we got a polar equation by using the formula, and by hypothesis a polar will be there. That means here we have to use the concept here. Therefore, since 1 and 2, 1 and 3 represent a same line, then we will get here, if any two lines represent the same line, then the x coefficient ratios, so the corresponding coefficients ratios are equal. That means here x1 plus g is the x coefficient of third line, and x coefficient of first equation is L. That means x1 plus g by L is equal to y coefficient of third line is y1 plus f by y coefficient of first line m is equal to constant term of the third equation x1g plus y1f plus c by here n. So this is equation number 4. So by using this one we'll find the values of x1 and y1. Okay. So equating first one and last one, we get x1 plus g by L is equal to x1g plus y1f plus c by n. Okay. Okay, let it be so suppose here you have taken this identity as R. So say this is R, not R exactly, say this is K. Say this is identity 1, 4. Now equating first and last, we get here x1 plus g by L is equal to K. For that x1 plus g by doing cross multiplication KL. Now x1 is equal to KL minus g. So this is x1 value. In the same procedure, equating second and last, we get y1 plus f by m is equal to k. For that you get y1 is equal to km minus f. Now equating third one and last one, we get, equating third one and last one, we get x1g plus y1f plus c by n is equal to k. Now x1g plus y1f plus c is equal to, doing cross multiplication, nk, and put x1 value. What we got here, x1 value. Now x1 is equal to, here this is the x1, lg kl plus g, and y1 is km plus f. So I have to take this copy here, kl, this one, this is x1 answer. Now you can write here x1 kl plus g in this one, kl plus g, sorry, kl minus g, kl minus g into z, plus y1 answer km minus f into f, plus c is equal to nk. Now substitute carefully here, klg minus g square plus kmf minus f square plus c is equal to nk. Now without k term can be taken left side, klg plus kmf. Now here k term is on right hand side, take it to left hand side, minus nk. Now remaining term will be, take it to left right side, you will get g square plus f square minus c. So we know that by taking k common here, lg plus mf minus n is equal to, we know that this is g square plus f square minus c. This is, if you have a root here, this will becomes to r value, that is radius of the circle. So there is no root, we can take r square. Now finally k is equal to, what is that, r square by lg plus mf minus n. Okay, this is the k answer. Now if you put k value in x1, what is that, this is the x1 value. So in x1 you will get here, put k in x1 and y1, we get a polar p x1 comma y1 is equal to p minus g plus lr square by lg plus mf minus n minus f plus mr square by lg plus mf minus n. This is the formula to find the pole when a polar equation will be given. Okay, now the concept is, this is the problem. Okay, this is the formula to find the pole when a polar will be given. I have explaining simply, to find the pole when polar will be given, first you need to find the center. So center formula is minus g comma minus f. This is the formula. Simply you can substitute the center. Okay, simply you can put the center. Center means minus g comma minus f, that will be in this equation. You will get carefully this one, lg plus mf minus n, and after that x coefficient into radius. Okay, to find the pole you should find the first center, after that radius. Okay, and then substitute carefully in this equation, you will get the pole. Okay, look at the problems on this model. Okay, suppose here if the circle is in the standard form, now this formula will be turned into this one here. If Lx plus my, that means we have to write here in this method. Here the equation of the circle can be taken in the standard form. X square plus y square is equal to r square. Now here x coefficient, what about the g value, f value? They will becomes to 0 here. Now this will be 0 and this will be 0. Now g, f values are also 0. You can get here, this is the procedure. Okay, minus this one. Here also you get. What will be the answer you can get here? Lr square by minus n, mr square by minus n. So simply this can be written as minus Lr square by n comma minus mr square by n, minus Lr square by n comma minus mr square by n. So look at here, in this method the polar will be the general form here. Suppose, so remember these two conditions. Okay, so when a circle is in the general form, you have to use to find the pole this formula. When the circle is in the standard form, you have to use the formula for the polar is this one. Otherwise you can use to find the pole the general process. That means by taking p x1 comma y1 is the pole and find the polar equation s1 is equal to 0 and comparing this equation with the given hypothesis equation and represents the these two lines represent the same property, same line, then you will get the corresponding coefficient ratios are equal and then you can solve, you will get x1 and y1 answers. That is the way to find the pole of the polar. Okay, that is the procedure, and the very short procedure will be followed by these two formulas. Okay, have a look on these problems, this model. Okay, look at the problem here. Find the pole of the line 3x plus 4y minus 45 is equal to 0 with respect to the circle. X square plus y square minus 6x minus 8y plus 5 is equal to 0. This is the problem. So look at here what are given here. You have seen here a line. So first you need to take the given line 3x plus 4y minus 45 is equal to 0. Good. Next, what is that? Given circle will be there. You have to write given circle is x square plus y square plus 6x, sorry, minus 6x minus 8y plus 5 is equal to 0. This is the circle. So what you should find out to find the pole? So to find the pole we have to use the formula this one, because of the circle is in the general form. When the circle will be general form, you should use this formula. For this one you need to find the L, M, N values and G, F and R values. So for that the L, M, N and N will be getting by the equation 1. So here x coefficient can be taken as L, y coefficient can be taken as M, constant will be taken as n minus 45. So after writing this one, you can find the center of the circle. So generally the formula for center is minus g minus f. Remember one thing, to find the center of the circle must be in the general form. So the given circle is also in general form. You should find the center like that. Half of the x coefficient of negative, that is 3, half of the y coefficient of the negative, that is 4. So here comparing, then you get g is equal to minus 3, f is equal to minus 4. So we use this g value, f value. After the radius r is equal to, the formula will be using g square plus f square minus c, but you can write here directly 3 square plus 4 square Now constant term in the circle equation, that will be 5. So that is root of 9 plus 16 minus 5, that is finally root 20. So this is the radius. R is equal to root 20. Now to use the formula for pole, all variables will be find here. So now the pole of the line 1, the pole of the line 1 is the formula P minus G plus LR square by LG plus MF minus N, comma minus F plus MR square by LG plus MF minus N. Okay, this is the formula we have to use. Okay, now substitute the corresponding values in this one carefully. So minus G means minus 3 plus L means here 3 into R square, R means root 20 square, by LG 3 into G means minus 3 plus M into F means minus 4 minus N means minus 45, N means minus 45. Now the same process, minus F, minus of minus 4, next plus M means 4 into root 20 whole square by LG, that means same denominator, you can write here carefully. Here you can write this one. So careful while you are going to simplifying. Plus 3 into squaring and root cancel, 20 by 3 3s are 9. Sorry, here we did not substitute the value of M. What is the value of M here? Here also M4. Okay, this is the simplification. Now write carefully. 3 plus 3 into 20 by here minus 9 minus 16 minus 20, minus 20 plus 45, minus 20 plus 45, 25, sorry 25 plus, minus 25 plus 45 plus 20, 4 plus 4 into 20 by 20. Now cancelizing 20 here, you can get here 3 plus 3, 4 plus 4. So the answer should be 6 comma 8. This is the pole. Therefore pole is 6 comma 8. Okay. Next problem. Have a look on this problem. This is the very important for the 4 marks question. So to find the pole, first we need to find the center and radius. After that, by using the given line, you can find L value, M value, N value. After that, directly you can substitute these values in the pole equation. Pole formula minus G plus LR square by LG plus MG minus N minus F plus MR square by LG plus MF minus N. Okay. Okay. Have a look on these two problems. Okay. Take these problems as a homework sums and find the pole. Okay. So remember one thing, when the circle is in general form, you can use the long formula, that is minus G plus LR square by LG plus MF minus N and minus F plus MR square by LG plus MF minus N. If the circle is in the standard form, then you can use simple formula minus LR square by N comma minus MR square by N. This is the formula when you should use this formula. This can be used when the circle is in the standard form. Okay. So in the homework sum, the circle will be general form So you can use the formula to find the pole. This is okay. Now we are going to discuss about the conjugate lines. Okay, conjugate lines. Now the definition of the conjugate lines are, so when you say that the two lines L1 is equal to 0 and L2 is equal to 0 are the given two lines here. Now we say we are going to set that these two lines are conjugate. The conjugate meaning is, by taking first line and circle we need to find the pole. Now that pole will be substituted in the second line, it will satisfy. So that is the simple conjugate of the simple concept of the conjugate lines. That means the conjugate lines definition is, the two lines L1 is equal 0 and line 2 is equal 0 are said to be the conjugate lines with respect to the circle S is equal 0 if the pole of the first line lies on the second line. That is the concept. Okay, have a look on this problem here. This is the condition that the two lines are said to be the conjugate for a circle. Okay, so to show that the two lines are conjugate, it is enough to use this property. Otherwise, one more procedure. By taking the first line, you can find the pole that will be substituted in the second line. It will be satisfied by that pole. Okay, that is the another process. Okay, so to showing the two lines are conjugate, there will be two processes are there, by taking this property, otherwise by direct process. Okay, the direct process will be done by this following method, following theorem. Okay, so now the solution of this problem. Look at here, what are given here. You have seen here line 1 and line 2, lines L1x plus M1y plus N1. This is line 1. Next L2x plus M2y plus N2 is equal to 0. This is line 2. Now given circle will be there. Given circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Already we know that, let it be equation S. We know that the center c minus g comma minus f and radius is square root of g square plus f square minus c, or this can also be written as r square is equal to g square plus f square minus c. Okay, now so look at here the problem. The lines first line and second line are conjugate with respect to the circle. That means given that here line 1 and line 2 are conjugate. By the definition of conjugate lines, the pole of first line lies on the second line. That means now we are going to find the pole of the line 1 with respect to the circle S is equal to 0 is, general formula is minus g plus LR square by LG plus MF minus N. This is the formula. Next, minus F plus MR square by LG plus MF minus N. This is the formula. But in the equation 1, it having x coefficient, y coefficient as L1, M1, M1. So that means in the place of LM we have to write L1, M1, N1. Here also L1, M1, N1. This is the pole of the line 1 with respect to the circle S is equal to 0. Now given that the two lines are conjugate means the pole of the line 1, that means this point say P, this point P satisfies the equation number 2. Now since 1 and 2 are conjugate lines, therefore P lies on line 2. Now we can substitute x1 is this one and y1 is this one in this equation number 2. We can get here L2 into x means x coordinate. What is the x coordinate? Minus d L1 r square by L1g plus m1f minus n1 comma minus f plus m1 r square by L1g plus m1f so L2x, x means this one, plus m2 into f means you can substitute here minus f plus m1 r square by L1g plus m1f minus n1 plus n2 is equal to 0. Okay, now simplifying here, minus L2g plus L1 L2 r square by L1g plus m1f minus n1 minus plus into minus minus m2f plus m1 m2 r square by L1g plus m1f minus n1 plus n2 is equal to 0. Now here we have to write fraction part on left hand side, remaining on right hand side. You will get is equal to L2z plus m2f minus n2. Now they are like fractions. This is n1, so now L1 L2 r square plus m1 m2 r square is equal to minus n2. Now doing cross multiplication, L1 L2 r square m1 m2 r square is equal to L1g plus m1f minus n1 into L2g plus m2f minus n2. Now on left hand side we have to take r square common, L1 L2 plus m1 m2 is equal to L1g plus m1f plus n minus n1 L2g plus m2f minus n2. So this is the condition that when two lines will be given, that line should be conjugate. Okay, remember that this is the conjugate lines property. Okay, look at here, they are the properties for the two lines are said to be the conjugate. So when the two lines will be given and a circle is in the general form will be given, the condition that the lines are conjugate is this is the property. If the two lines will be given and circle is in the standard form will be given, then you should use the property for conjugate lines is r square into L1 L2 plus m1 m2 is equal to n1 n2. Because of in standard form g value f value will be 0. If you substitute g f in this equation as 0 0, you will get this answer. Okay, have a look on this problem. Okay, this is the problem. Have a look on this problem. I will tell you this problem in simplest method. So to use this method, you have to remember the conjugate lines property here. So look at here the problem. What will be given here? Here two lines are given, this one and this one, line 1, line 2 are conjugate with respect to this circle. We have to show that these two lines are conjugate. Okay, so first you need to write the lines. Given lines are 2x plus 3y plus 11 is equal to 0. Okay, next one, 2x minus 2y minus 1 is equal to 0. Okay, for these two lines you can write by taking first line L, M, N. The first line you can take L1, M1, N1. So L1 is x coefficient 2, M1 is y coefficient 3, N1 is 11. By taking second line you can write here L, M, N. So if you take in second line you can write L2, M2, N2 here. So L2 is 2, M2 is minus 2, N2 is minus 1. So need not be write this L1, M1, N1, L2, M2, N2 value. Okay, if you want to write, then write them, otherwise there is no problem. Okay, next, so for this, after writing these values, given circle, here given circle is x square plus y square plus 4x plus 6y plus 12. Once I have to check the given circle, x square plus y square plus 4x plus 6y plus 12 is equal to 0. After writing the circle equation, compulsorily you have to find the center. The formula for center is minus g minus f, that is equal to negative of half of x coefficient, that is minus 2, negative of half of y coefficient, that is minus 3. So that is minus g is equal to minus 2. That means you can write directly g is equal to 2, f is equal to 3. Next, radius. Therefore radius r is equal to, what is the radius formula? G square plus f square minus c. So that is root of 2 square plus 3 square minus c means constant 12. So that is root of 4 plus 9 minus 12, that is root 1, that is equal to 1. Therefore r is equal to 1. So after finding r square is equal to 1, so what we have to find here, show that the given lines are conjugate. Now the conjugate property is, therefore r square into L1 L2 plus M1 M2 is equal to L1G plus M1F minus N1 into L2G plus M2F minus N2. Okay, this is, now we are going to show that the LHS and RHS both are equal. For that, here you have to write r square. R means 1 square. So directly you can multiplying x coefficient 2 into 2 and y coefficient 3 into minus 2. So that is the LHS side, 2 into 2 plus 3 into minus 2. 2 into 2 plus 3 into minus 2. Otherwise directly you can put L1, L2, M1, M2 answer. On right hand side, simply you can substitute the center coordinates in the equation 1 and equation 2. Here I am going to copy the equation 1 and equation 2 here, roughly here. Okay, on right hand side, don't worry to substitute directly here. This point in this equation, how much you will get? 2 into minus 2 plus 3 into minus 3 minus plus 11. Next, in the same process, this point will be substitute in this equation. 2 into minus 2, minus 2 into minus 3, minus 1. Okay, so because of, if you substituting like that, that means I have taken here minus in this one and also minus in this one, you will get minus into minus plus. Okay, so there is no need to worry about that. So now 1 square means 1 into 4 minus 6 is equal to minus 4 minus 9 plus 11 into minus 4 plus 6 minus 1. So for that, 1 into minus 2 is equal to minus 4 minus 9 minus 13 plus 11 minus 2 into here minus 4 minus 1 minus 5 plus 6 1. So finally on left hand side minus 2, right hand side minus 2. So that is the condition of this one will be satisfied here. So hence we say that given lines are conjugate. Therefore given lines 1 and 2 are conjugate. 1 and 2 are conjugate. Okay, this is the way to show that the two lines are conjugate. Okay, otherwise one more procedure will be there, so I will explain that one. Okay, try this problem, try this method. So here given two lines are there. By using the first line, you should find the pole. Okay, after getting the pole, you can put that pole into second equation, you will get the answer. Okay, so that is the second method of this problem. Okay, next, okay, have a look on this problem, the same model. So read the given problem carefully. Find the value of k if the lines this one and this one are conjugate with respect to the circle. That means in the given problem, two lines are given and one circle will be given, and he say that these two lines are conjugate. So by using that property, you have to find the value of k. So for that, first we need to take the given lines. Given lines are x plus y minus 5 is equal to 0, 2x plus ky minus 8 is equal to 0. So this is equation 1, this is equation 2. So if you want to write, then write L1 is equal to 1, M1 is equal to 1, N1 is equal to 5. Next, L2 is equal to 2, M2 is equal to k, N2 is equal to minus 8. Okay, so they are L1, M1, N1. Now write the given circle. By taking given circle, you have to find the center and radius. So for that, center formula is minus g minus f. So simply you can make the negative of half of the x coefficient, negative of half of the y coefficient. You will get g is equal to minus 1, f is equal to minus 1. Next, radius, r is equal to square root of g square plus f square minus c. So for that, g square means 1 square plus 1 square minus c means here constant, minus of minus 1 plus, that is 1 plus 1 minus 1, that is root 1 is equal to 1. So you got radius r is equal to 1. So what is the given problem here? So here given 1, 2 are conjugate with respect to the circle 1. So circle is in general form, therefore given condition, given that the lines 1 and 2 are conjugate. So what is the property for conjugate lines? R square into L1 L2 plus M1 M2 is equal to L1G plus M1F minus N1 into L2G plus M2F minus N2. So this is the conjugate lines property. For that I have to take the copy of the given line here, given lines. So because of simple substitution, so by taking the copy of this one, so put there, they are the given lines here. Okay, now simply here r square means radius. How much you will get radius? 1. So now 1 square into simply x coefficient product 1 into 2 plus y coefficient product 1 into k. How much? K over is equal to, simply you can put the center in this equation of left hand side. You will get 1 plus 1 minus 5 into, in the same process, this point in this equation you will get 2 into 1 plus k into 1 minus 8. Okay, so now simplify here. 1 square means 1, 2 plus k is equal to 1 plus 1 2, 2 minus 5 minus 3 into 2 plus k minus 8. Now finally 2 plus k is equal to minus 3 into 2 minus 8 minus 5. So now producting here, 2 plus k is equal to minus 3k, minus of minus plus, 3 5s are 15. Now bring out, take it the k terms left side, remaining are right side. Now k plus 3k is equal to 15 minus 2. So finally 4k is equal to 13. 4k is equal to 13, k is equal to 13 by 4. This is the value of k. Sorry, here a simple mistake will be done here. So here 2 minus 8, 2 minus 8 answer will be minus 6 here. So we can write here minus 6. Now simplifying here, 2 plus k is equal to minus 3k, minus into minus plus, 3 8s are 3 6 are 18. Now take it k values all left side, k plus 3k is equal to 18 minus 2, that is 4k is equal to 16. Then k is equal to 16 by 4. 4 1s are 4 4s are. Now finally you can get k is equal to 4. This is the way to find the value of k when the lines are conjugate. Okay, have a look on these problems. Find the value of k if the lines are conjugate with respect to the circle. By taking the conjugate condition, then find the value of k here. In the second sum, read the given problem carefully here. Find the coordinates of points of intersection. Here point of intersection of the tangents at the points where this line meets the circle x square plus y square minus 2x plus 3y plus 5 is equal to 0. So read the given problem carefully here. So this problem will be asked indirectly here. By the definition of pole, what is the concept here? This is the pole concept. That means find the coordinates of the point of intersection of the tangent at the points where this meets the circle x square plus y square minus 2x plus 5 is equal to 0. That means it is enough to find the pole of this line with respect to this circle. That means directly you can find the pole of this line with respect to the circle. So this is the concept of this class. Okay,